Alrighty, time for your next test review. This is your easily sounding teacher, Mr. Patch, giving you these great little skills to help you get ready for your next test. Try not to fall asleep and enjoy the relaxing sounds as I try to help you get ready for your next test. Yeah, I can't do it. I just got to be awake. Alright, moving on. So let's look at this. So let's look at number one. The whole P divided by Q thing. Okay. So, some of the things that we discussed about this. For part A, you got to give me the P's and the Q's, and then do the P's divided by Q's. So you can see here, like we're looking for the P's, all the factors of 60. And you might want to try to come up with the idea of, like, how do I make sure I've covered all the numbers? Well, why not put the pairs together? Like, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. And then, that should hopefully cover them all. I don't know if I'm going to make you give me the ones, or I'm going to tell you how many there are. I think this time I'm just going to do it straight. Anyways, P divided by Q is basically the same thing. So again, plus and minus. Let's go all the way. There you go. There they are. Boom. All right. So now we got to try these numbers. Now what do we do next? So we go to the graph. Hey, look, there's a graph. Isn't that a cute little graph? There it is. There's the graph right there. Okay, now let's go. So you can see there, it looks like at -5, -3, and +4. But try the numbers. I want you to show me the synthetic division. You have to prove that those are correct, that you see it correctly, and that you can count. Because, well, sometimes some of y'all, I'm not so sure if you can count. Anyways, so we're going to put in the -5. Bring down the 1. 1 times -5 is -5. 4 minus 5 is -1. -5 times a -1 is +5. -17 plus 5 is a -12. Most of this stuff you can easily do in a calculator, by the way. And then -12 times a -5 is +60 and gives you a 0. So yes, -5 does work. Let's continue on and go on to -3s. So starting at the next one. -3, boom. Down 1, -3. -4, +12, 0. So that one works. Yay! And finally we'll try 4. 1, 4, 0. Bam! And there you go. So, that's all that one is. There you go. Let's look at number 2. Number 2, we got the 6 and the 5. Okay, so let's look at this. I'm going to back this up a bit for you. So you got the 1, the 2, and then for the Q, you got 1, 2, 3, and 6. But now you notice, okay, 1 and 2. And then now you're saying 1 divided by 2 is 1/2. 2 divided by 2 is 1, which you already have. So now we can go to 3. So 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. And now you can go to 6. 1 divided by 6 is 1/6. 2 divided by 6, whoopsie, simplifies to 1/3. So I've got all my numbers there. There's the graph. Go back to this because I'm going too fast. There's the graph. Okay. There's the numbers. Those are all my possibilities. So now when I look at the graph, whoops, moved over too much. Okay, so let's get there. -1 you can, or 1, yeah, -1 you can see, which is right here. You can see is there. Okay, this one right here looks like it's at -1/2. And again, those are possible answers, so you try them. Okay, so you try -1/2. You bring the 6 down. Remember, all that fraction is a dividing. I don't know why y'all get all freaked out about fractions. You multiply the top number and then divide. Okay, so 6 times 1 is 6, divided by 2 is 3. So half of 6 is -3. -1 and -3 gives me -4. Then you divide again, got 2, positive, got an answer of 0, bada bing, bada boom, there you go. So -1/2 does work. Now this one right here looks like it's close to 1, okay? So then you try the 1, or something close to 1. The closest fraction to 1 was 2/3. And lo and behold, it does work. Don't just give me numbers and say they automatically work. Double check, actually do the work and show me. And by the way, also on there, what was I going to say? Okay, so you've got those. You should be able to do this. You can do a menu trace thing, menu 5-1, to say try to trace them, but do give me the fractions. Don't go back and give me the decimals. So like if it's telling you that this crosses at, say, -1 or -0.6, or I'm sorry, 0.6, positive 0.6, then realize that 2/3 and 0.6 are about the same. Okay, moving on. Look at number 3. Oh, there's just a lot there. Okay, so here's number 3, and there's all the P's and Q's. or the p's, all the factors of p's for 120. Notice how it went 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 8 and 15, 10 and 12. I'm out of breath. And then the key was just plus minus 1. So rather than rewrite, I just wrote the arrows and put p divided by q, and there's okay, they're all those numbers, because that's a lot. And you got to save yourself some time on the test. So you can do something like that if there's not going to be any fractions. All right, so let's look at the next part. There you can see there's only going to be 2 real zeros. So it looks like one is at -5, so you try -5. So you put your numbers there, and then you try -5, and you can see that's going to work. Okay, -1 minus 5 is -6, times -5 is 30, 4, -20, 24 gives you 0. Bada bing, bada boom, you try 6. -5 does work. Bring down the 1, 6 times 1 is 6, 0. 0, 4, 24, 0. Got an answer? Yes, it is. Okay, now, that's x to the 4th, x cubed. That means the last row is an x squared. So that is x squared plus 4. We move the 4 to the other side. Take the square root, and the square root of 4 is 2, but we always put plus and minus. And because it's a negative, there is an I. Bam! And now I have all 4 of my answers. So simple, isn't it? I know. I try to do my best to help y'all out. Anyways, all right, so now let's look at the next part. Number 4, let's talk about this. This 3x plus 2 business. Okay, so this is a growth. Let's see here. I'm going to come back to here. You might want this for your note card. Make note that with a negative in the very front, we have a reflection, and the range will be like y or f of x less than whatever it may be. The k is plus or minus. You might want to make note that on the k, if you have a plus or minus, that will change your range. Normally my range and my asymptote should be at 0. But if I have a plus or minus some number at the end, then that will change it to that number. Okie dokie. So now we go back. Alright, so let's look at this. So we have a growth because of the number, the 3. If the number with the exponent is bigger than 1, it's a growth. If it's between 0 and 1, it's a decay. Okay, then I have domain all real numbers, something that should be easy. Hopefully you can't miss. Range f of x greater than, now normally again it would be 0, but I see the plus 2 at the end, so now it's greater than 2, which means my asymptote will also be 2. Okay, because the range and the asymptote should always match up. So there's an invisible boundary at 2 that will kind of give me there. Alright, so then, get the table. Fill it in. You're going to have to say the -2, -1, 0, 1, 2 will be given to you. You just look it up on your calculator, graph the function, press Control-T, and then you can say come up with those numbers, and then plot the points on a graph. Now, the green line that you see there, that's the asymptote. That's the boundary. That's what it's supposed to be approaching, but it doesn't touch. I'm not requiring that you draw it, but one day I might. So, but you know, you might start getting used to the idea and kind of visualizing it. If you do go past it, I will count off points. So don't go past your asymptotes. You can't cross the boundary. It's a fence, and you can't go past. Okay. Okay. So moving on. Number 5. Okay. So we got this one, and this is a decay. Why is it a decay? Because the number is less between 0 and 1. Not worrying about the negative. The negative has nothing to do with it right now. Okay, domain is all real numbers. Now the range. Now because of the negative, the range, instead of being greater than, is less than. Because of the negative, it will change that symbol to a less than. Something to make note of on your note card if you haven't already. And it's going to be less than 0 because, again, that's standard unless there was a number after the exponent. The asymptote is at 0. And then we go from there to say, give me the table, bada bing, bada boom, there's your table, coming up right there, there you go. And those are the numbers, and then you could try to graph it. Now, you can see here, what I'm trying to do is I'm trying to plot the points and kind of come up with a graph. So you can kind of try to plot the points a little bit. My main concern that I'm going to be seeing is going to be looking for that y-intercept. So I'm going to be kind of like paying attention to that, and then that you have a general idea of the right direction that the graph should be going. Alright, so let's look at number 6. Number 6, number 6 is always fun. Alright, so number 6 is a decay because of the 1/3. Not because of the 4, because of the 1/3. Okay, it's greater than 0 because, again, it doesn't change anything with the unless there's a number being added or subtracted afterwards. The asymptote is also 0. Get your graph or get your thing and then just try to plot some points. So get your table. Again, graph it, make a new page. Control Doc makes a new page, and then that's something you can, and then you just add a graph, and then you type in the next function. Okay, and then you press, and then you got the graph. Again, notice how I kind of made some rough marks to kind of get it. I'm mainly concerned, I mean, it's not even perfect. You can see I'm a little bit off my point anyway. But there you go. And that's how you get that one. All right, so number 7. I've decided to just focus mostly on the transformations. So f of x is going to be the parent function. G of x is going to be the transformed function. So because of the negative in front, that's a reflection. And because of the plus 4, now that's part of that h part, that goes to the left or to the right. You can go back earlier into this thing and you can see where that would be to the left or to the right. I'm not going to worry about the graph. I'm just thinking outside the box now. But you can kind of see this is what the normal function would have looked like. Flipped it, I would have gone from, instead of crossing at 1, I would have crossed at -1. See, most functions cross at 1. So instead, when you do the reflection, you cross at -1. And then that plus 4 moves that spot, that green dot, over 4 spots to the left. So you can kind of see where that goes, and there's that it. And you can kind of see how that looks like it was shifted over. Okay, number 8. Okay, so here's an example. As I kept going over this with y'all, I started realizing maybe it's a little bit harder than I want it to be for, say, a rough graph. But let's focus on this. The 4 means, since it's in the very front and is bigger than 1, means there is a vertical stretch. So that's the A number that causes a vertical stretch. And then it's a decay, but I don't need to worry about that. And then I'm looking at this, the plus 2. Because again, these two are the same. This is the parent function. The plus 2 tells me it's after the exponent, so that means I'm moving up 2. So this one would be, say, a vertical stretch by a factor of 4 moved up 2. And that's all I care about right now. I mean, you got the right idea, you got the general thing, you can do it, not a problem. I mean, easily, if I asked you, you give me the table and then be able to draw some points, because I know y'all can do that, because y'all are just awesome like that. All right, so now let's look at number 9. Okay, so here we are. We're down to the last 2 problems. Yay! Okay, so here, look, you got 5,000, 6.5% growth, 15 years. Growth means you're going to add. So we have a function that tells us that if, like, we have something like this, for part A, I want the function 15 years equals the initial amount, which is 5,000, 1 plus, because of the growth, plus is the growth, change this to a decimal. So remember, 6.5, you're going to move it 2 spots over. Every single time you're going to move it 2 spots over, fill in the blanks with a 0. So you have 0.065, and then you're going to raise it to the 15th power. You press enter, and that's your answer for part B. And that answer should be $12,859.20. So happy, happy, joy, joy, the money's been growing. Yay! Okay, and that's all you really got to do. I want part A and part B. There you go. Very simple. But make sure you're careful about moving the decimal over and changing those percents to decimals. All right, the last one about this nitro swimming. Look, cost $18,000, depreciates, that's a minus 9% annually for 10 years. And just in case some of y'all complain, you can't see. There you go. Switching to yellow. All right, so again, we're saying A, for part A, 10 years, initial amount is $18,000. We're saying 1, because it depreciates, that's a minus, and we're changing this 9% to a decimal, which means 0.09 raised to the 10th power. And you press enter, and you have your answer for part B, and that answer is $7,009.49. All right, kiddos, there you go. I know y'all are being awesome about things. Try to be patient with me. I've been trying to be patient with y'all all the times. But just keep doing the great job y'all are doing. All right? No secret word today, because I already did a secret word during the notes before. So nice try. Y'all take care, and I will see y'all tomorrow. Good luck.